Good day, grade nines. We're looking at area and perimeter over the next 2 days, and you would have noticed that we moved the dates to give you another extra day off previously. So this might not be on the 10th and 11th of June that you're going to receive this video. So now the revision on area and perimeter. Firstly, we're looking at the document term 2, topic 4, where you can go read through the pages 1 till 10. Just a few reminders about the conversion factors. If you go from millimeters to centimeters, you divide by 10. Then if you go from centimeters to meters, you divide by 100. As you can see, if we go this way, in other words, smaller unit to bigger unit, we divide. And then if we go from meters to kilometers, we divide by 1,000. Then if we go from big to small units, we times. So from kilometers to meters, there's 1,000 meters inside a kilometer, so we times by 1,000. Then from meters to centimeters, you would times by 100, and from centimeters to millimeters, we would times by 10. Here are the conversion factors, and then you must learn your formulae, as we've done a video previously for this, and then the units of measurement must be the same. Very important to remember before you do any calculations. Then you must use brackets when you substitute, or else it does not make sense mathematically when you get to the different answer. Then we're looking at together. So it's a summary worksheet and it's on area and perimeter. And so firstly, this is a square. We must find the perimeter and the area. And then the square has side lengths of 3.5 centimeters. Now, just by the way, you never really have to write your formula. The formula is indicated as the correct formula by the way you substitute it. So for the perimeter, remember you can just add all the side lengths together. So for the perimeter, it would be, since it's 4 of the same measurements, length plus length plus length plus length, but there's a better way to write it. So we rather write there's 4 of these lengths all together. So 4 times that length gives you the same measurement as adding all those lengths together. So 4 times that certain length, and that is 4 times 3.5 centimeters. So therefore the perimeter is 14 centimeters. So that's the measurement around the shape. Then for area, that is calculated by multiplying the length's measurement by itself. So that would be 3.5 centimeters times 3.5 centimeters basically. And then that gives me 12,25 centimeters squared. Remember, area would always be written in square units for the answer. Now for the rectangle, straightforward. Once again, we would literally go length plus width plus length plus width. But rather than that, I notice that I have 2 lengths and 2 widths. So a better way to write it would be to just go and say 2 of the same length measurements plus 2 times the same width measurements. And that gives me, when I substitute, 2 times, and the length measurement is normally the longest measurement, so 52 millimeters, but I'll write in here 2 times the measurement of 52 units plus 2 times the measurement of the width, 18 millimeters. So as you can see, all the while I'm substituting those values into brackets, or else it does not make sense. If I put all of that into my calculator, it tells me that the perimeter is 140 millimeters, and that's it. Okay, so I'd put it just like that into my calculator and it gives me the straight answer. Now for the perimeter, the area, sorry. That would of course be where you multiply your length with your width, and the length's measurement, as we saw, was 52 and the width's measurement is 18. And then that is equal to 936 millimeters squared. Just a reminder that area is square units every time. On to the next part. Now with a triangle, they tell you as a note here, use your knowledge of Pythagoras to help you find a missing side or perpendicular height of the triangle if it is necessary. So that happens normally when we're working with an isosceles or an equilateral triangle. Okay, and then your perpendicular height is sometimes not provided. So that's why they say missing side or perpendicular height of the triangle. So they tell you here A is equal to 5 centimeters. There's A. B is 6 and C is 5 centimeters. And this time around they did give you the measurement of the perpendicular height, so you don't need to go calculate it. So we go ahead and we do our calculation. So the perimeter formula is just add all the sides, A plus B plus C basically. Okay, so we don't even need to write a formula for this, but I'm doing that. So 5 plus 6 plus 5 centimeters is the calculation then, and that gives you 16 centimeters as the perimeter. Now for the area, that's where we need the perpendicular height, because it is the formula of half base times perpendicular height, or it could also be written as base times perpendicular height divided by 2. Irrelevant of the way in which you use the formula, we now substitute the same values. So I'm not going to do an or here now. Let's just substitute into this formula. Let me show you. So it's half of the base value, and the base value is the B. It's labeled B here. Okay, where your perpendicular height meets your base value. That's where you find the measurement you substitute into B here. And they said that that is 6 centimeters times the perpendicular height value as provided over here is 4 centimeters. So times 4. And now it's just really irrelevant of the order in which you calculate it, because it's all multiplication. But if you put all of this into your calculator, it will provide you with an answer of 12 centimeters squared, or just 12, but remember the units must be squared. Now for circles, a few different types of circles. So firstly we're looking at a normal circle, where the formula for perimeter, let me just write here perimeter. Well, I'm going to write perimeter or circumference, because for a full circle it's called a circumference, but for these other ones, the 3/4 of a circle, half a circle and quarter circle, we would refer to the measurement around the shape as the perimeter again, and or the area will be calculated in this column. So now the formula for the circumference of this circle is pi times diameter, or 2 pi times the radius. And as I've been provided with a radius measurement, it's easiest to just go and substitute that value into 2 pi r. So then we go and say it's 2 multiplied by the decimal approximation of 3,142 multiplied by the radius value of 7, and then therefore the circumference value would be 43, and it says 988, but I'm going to round it to 2 decimals, so 99 centimeters. Now for the area, the formula is pi r squared, and we just substitute our radius into that placement, and then pi's decimal approximation of 3,142. So then the value for the area gives us 153,96. It's 958, but of course I'm going to round it to 2 decimal places again, so 96 centimeters squared. Okay, then for the semicircle, we have to just remind ourselves here, they said, so a diameter is given, but remember, in general, for the rest of these, the radius would be when you take the diameter measurement and you divide it by 2. So now, for the semicircle, it's just half of the formula for the area. And for the 3/4 of a circle, it's just 3/4 of a circle for the area. And so for the quarter of a circle, a quarter of the area formula. So you can just divide by half, times by 3/4, and times by a quarter for the area formula. But it's a bit different for the perimeter. So if we just go and say half of the perimeter formula or the circumference formula, then it just goes from this point around to that point. So if we want to go fully around this shape, we would have to go this distance as well to make it come full, well, I don't want to say circle, but to come fully up to that point where we started, to close it. So that is the diameter, which in other words, if the radius is given, is 2 times the radius, twice the radius. So basically for your semicircle, the perimeter is equal to half of 2 pi r, okay, or half of pi times diameter. So the way it could be written is 2 pi r divided by 2. But that, may I remind you, is this distance up to that point. So we need to still add in the diameter. So plus the diameter, which is also known as double the radius value. Okay, and then we just substitute. So it is going to be 2 times pi value, 3,142, times the radius value, and then 76 divided by 2 is, so that's the radius, is equal to 38 millimeters. Okay, so that is then 38, and that's all divided by 2 plus double the radius value of 38 again, which is basically just your diameter. I could have just as well said 76 there. So that gives us 195,396. So if we round 396, it becomes 0.40. You don't necessarily need to write the 0 millimeters around the shape. And then for the area, it's quite straightforward. We just go and say pi r squared divided by 2. Okay, so if I substitute, that becomes 3,142 times the radius of 38 squared, and that should be divided by 2. And so I'm just going to write over here the area value is equal to 2,268,524, and this time it rounds down to 52, and the units, of course, millimeters squared. Now I don't have enough space here. I'm squeezing. I'm sorry about that. Okay. Now we have 3/4 of a circle, and for that we just adapt the formula, and it becomes 3/4 of pi of 2 pi's radius. 3/4 of 2, let's just do that, pi radius, plus, once again, 3/4 of that distance is from that point, let's say 3/4 of the way, not fully, but only up to there. So that's just that part. But if we want to fully close this shape, we have to add in that radius and that radius. Therefore, 2 radii. So plus 2 radii. And then if we substitute 3/4 multiply by 2 multiplied by pi, which is 3,142, multiply by the radius, and that is 2,6 in the diagram, plus then the 2 radii of 2,6 centimeters. So if I put that on my calculator, I get 17,4538. So if I round it, it's basically just 4,5 centimeters. Now the radius is 2,6 again, and the area would just be 3/4 of pi r squared. And then if I substitute, it's 3/4 multiplied by pi 3,142 multiplied by the radius squared, so that's 2,6 squared. And then if I put that into my calculator, it gives me 15,92994, and if I round that, it's 0,93 centimeters squared. All right, and then the last one on this video is 1/4 of a circle. So 1/4 of a circle would of course then be adapted, and I don't know if you want to pause and try this on your own first and then come back and see how I do it, but I told you, so it will be adapted in the sense of whatever of a circle it is. So it's 1/4, so it's going to be 1/4 instead of 3/4 like this one, times the normal circumference formula plus 2 radii. That's kind of set. So this is 1/4 of 2 pi r plus 2 radii. And then if we substitute, it's 1/4 multiplied by 2, which is multiplied by pi's approximation 3,142 multiplied by the radius, this time being 45 millimeters, plus 2 times the 45 millimeter radius value. And if I put that into my calculator, it gives me 160,695. So the 5 would make the 9 go up, and then the 69 becomes 70. Once again, you do not have to write the 0, and that would be in millimeters. And then if we go on to the area, that would be, of course, 1/4 of pi r squared, which just means 1/4 multiplied by pi r squared. So if I substitute the values, pi's approximation of 3,142 and the radius value of 45, and I put it into my calculator as is, it gives me 1,590,6375, which rounds to become 64 to the nearest second decimal place. So that would be in millimeters squared. Okay, so you can check out. This is all the work you learned up to in grade 8 at least, and then I'm going to start a new video for the grade 9 work, new work basically.